Good morning students. So in this class we are going to discuss about galvanometer sensitivity, that is sensitivity of galvanometer. So first, figure of merit of galvanometer. So that is current required to produce a deflection of one scale division in the galvanometer is figure of merit of galvanometer. So what is the current required to make a deflection of one division? That is a figure of merit of galvanometer. So galvanometer is used to measure the current, already we know, and also ammeter is also used to measure the current. So what is the difference between ammeter and galvanometer? So ammeter, you are measuring a large current, so it's 0.1 ampere, 0.2 ampere. If it is galvanometer, it is in the microampere or milliampere we can measure. So galvanometer shows large deflection for very small current. That is the sensitivity of the galvanometer. So first, current sensitivity. So deflection produced per unit current flowing through the galvanometer. So that is deflection produced in the galvanometer per unit current flowing through the galvanometer. So that is current I, that is theta by I. So that is deflection produced per unit current flowing through the galvanometer. So it's theta by I. So already we know from the previous question. So I is equal to K by NAB theta. So there is a deflection due to the current flow. So here theta by I. So theta by I is NAB by K. Just rearrange. So you get NAB by K. So theta cancel. Then so that NAB by K is equal to, just see, I equal to G theta. So theta by I is equal to 1 by G. That is theta by I is equal to 1 by G. Just you can directly write it. Then so that I is the current sensitivity, that is current sensitivity of the galvanometer, that is equal to 1 by G. So current sensitivity is increased by increasing the number of turns, that is N. Then magnetic induction, then area of the coil, then current sensitivity is increased by decreasing the couple per unit test. So that is passer bronze wire is used for that moving coil galvanometer because it have a couple per unit test is very small. So if you decrease the couple per unit test, you will get the current sensitivity is somewhat more. The next, voltage sensitivity. So deflection produced per unit voltage. So here see, deflection produced per unit current, deflection produced per unit voltage. Flowing through, current is flowing, that is charge. So charge, flow of charge constitute electric current. Flowing through the galvanometer, here applied across the galvanometer. So voltage should be applied across the 2 points. So that is per unit voltage applied across the galvanometer. So that is voltage sensitivity is equal to theta by V, that is deflection per unit voltage. Then V is equal to IR. So according to Ohm's law, V is equal to IR. So just I into RS. So theta by I is equal to, so theta by I is equal to NAB by K. Just write it, NAB by K times RG. So RG is the galvanometer resistance. Then NAB by K is G. So NAB by K is G. That is 1 by G. So it's 1 by G. Just so 1 by G. Then RG, then 1 by G is equal to here 1 by G equal to IS. So just substitute IS. So voltage sensitivity is equal to current sensitivity divided by then galvanometer resistance, that is V equal to IR. So I is equal to VR. Just apply the Ohm's law. So in this class we have discussed that is sensitivity of the galvanometer. So galvanometer shows large deflection for very small current. So that is the sensitivity. So current sensitivity and voltage sensitivity. So deflection produced per unit current flowing through the galvanometer, that is current sensitivity. So it is increased by increasing the number of turns, magnetic induction, area of the coil, decreasing the couple per unit is. Then voltage sensitivity, deflection produced per unit voltage applied across the galvanometer. So that is Vs equal to, that is current sensitivity by galvanometer resistance. So okay students.